Okay, so try that one on number 12 here. Do what it takes to get that x alone. So what's our first step? We have x's on opposite sides, right? So what's our first step?
Do the opposite.
Do the opposite. Of which one? Really, you could do either one.
The lesser one, 36.
Yeah, so you could add 36 to both sides, or you could add 26, whatever. Just get rid of one of them. Just do the opposite of one of them. It doesn't really matter a lot. It'll work either way. So do that, see if you can get that. All right, so first step then is to, when you have x's on opposite sides, to do the opposite of the lower one usually. Minus 36, that's low, right? That's more negative than 26, right? If you're $36 in debt, that's worse than 26. So that's the lower one. I'm going to add 36x to both sides. If you added 26x, that's okay too. It'll work. Basically, just get rid of one of them. It'll be the right answer in the end, as long as you get rid of one of them. So what do we got here now? 10x minus 0.2 is 1.6. Good to there so far? What do we do next? Yeah, because now x is saying, I want to be alone. That's what x is always saying. I want to be alone, right? So that means we're going to get rid of the 0.2, the negative 0.2, and the 10 eventually. So the 10 is the last thing, right? We save the thing right next to x for last, don't we? Making sense? Kind of like peeling an onion. You do the outer layers and you work your way in, right? So we work our way. The last thing we do is the thing right next to x, and we're going to divide that. That's always the last step, right? All the rest is adding, subtracting. So get rid of the negative 0.2 by doing the opposite. Add 0.2. Is that good? These are gone. Bring down the 10x. The other side, 1.8. 1.8. Last step to get x alone. Divide by 10. Right? Last step is always divide, isn't it? Why? Because that 10 is right next to the x, which means it's multiplied. It's multiplied. So the opposite of multiplying is dividing. And now, remember what happens with the decimal when you divide by 10?
You move the point?
Yeah, it goes back one place, huh? You can just use calculator though. 0.18. And we're done. Are we good? It's making good sense? Questions I can answer? We're going to go to bigger and uglier things. If you're good, we're going to move on. My fellow's piece. So here we go. Okay, try that one. So you need to solve for x there. So you get x alone in that one. So what do we do to get x alone there?
We send 511 to divide 9 ones.
Yeah, because x is saying I want to be alone. What we do to get x alone, we got to get rid of the minus 511s, huh? So the reciprocal, the upside down, right? Multiplied by 11 over 5. Do you see how that'll cross-cancel the 11s and cross-cancel the 5s both all at once? And that almost gets x alone. What's still hanging there with x? The negative sign, right? Everybody see? The negative sign is still here. I want to get rid of that too. I want to get rid of everything. So what do I do to get rid of that negative sign? Use a negative here. Because two negatives multiplied will make positive or regular x. That's what I multiply both sides by. Is that making sense? Well, whatever you do to one side, you have no choice but to do the same thing to the other. How are we doing? Is that making sense? I multiplied both sides. So when you want to get rid of a fraction, do the upside down. Now let me, yeah, we'll just say that for now. If all you have is one fraction left next to x, do the upside down. In a minute, I'm going to change the plan with fractions. It'll be a little different situation, I'll explain. But for now, the upside down, the reciprocal, gets rid of both the 11 and the 5 and two negatives, make positive x, regular x, don't they? Everybody see that? Remember, two negatives multiplied make positive. Everybody see why I need to use the negative? All right, now I got to work out the other side. The left side is just x. How do you work out the right side?
You put 9 over 1.
Yeah, any whole numbers over 1, make it look like fractions over 1. And I cross-cancel if I can, but I can't, so I don't. Right? 5 doesn't go into 9. Right? I would if I could, but I can't, so I don't. So 5 doesn't go into 9. So then what do you do when it doesn't cross-cancel? Just go straight, huh? Right? So 9 times 11 is 99. 1 times 5 is 5. Two negatives, make positive, and we're done. How are we doing? Good? Matthew, question? Comment? No, I think they let us just put it, we'll go check. But I think they the only thing we have to worry about is if the top and the bottom are divisible by the same number. Like if the top divided by 5 or something, then you got to do that. But as far as the top being bigger, that's okay. They let us keep answers with the top bigger. What they don't let us do is like, what if you had 2 over 6? Can you leave it that way? No, because that divides by 2 top and bottom, right? So the only thing you have to do is divide anything that goes into both of them. But top bigger, it's okay. We can leave it. Let's go. Okay. So 17, I'm going to do something new. Got a new game plan. Notice we have fractions. Of course, we had fractions in the last problem. But this is a little different. The reason this is different is because there's not just one fraction next to x, and they need to get rid of that. Right? It's not just one fraction with x. It's several fractions. It's a couple of fractions. So let's go see it. So see the last problem? How I had minus 5/11 and minus 9? See how that was just one fraction next to x is all that was. So that we get rid of that by multiplying by the upside down. This one it's not just one fraction next to x. You tracking with me? It's a fraction somewhere else. It's a couple of fractions actually. So I hope you're seeing the difference. I'm going to do something different. What am I going to do? Let me write those steps in again. So what were the steps for solving? Step 1, clear fractions. Step 2, add, subtract. Step 3, divide by the number next to x or front of x. So step 1, clear the fractions. How am I going to clear the fractions? Multiply by 2, multiply by 2, multiply by 2. Does everybody see that? Why am I doing that? Well, because I need to get rid of that 2 from the denominator, huh? That good? Got to get rid of that 2 from the denominator. See how it'll cancel right there and cancel right there? Is that good? So those are gone. Go ahead and multiply that part in the front, if you would. So multiply out the rest of what is left. So multiply through by 2. And so 2 of them cancel. And then what is this one? What is 2 times minus 5x going to be minus 10x? We good there? Is that making sense? Minus 10x minus, and then these 2's cancel. And what is that? It's going to be a half, huh? And then this is 19. Let me pause right there. Is it making sense what I'm doing? So this is a new plan. See how I got rid of all the fractions? See how there's no more fractions? So that's what we're going to do. This will probably be the hardest kind of problem that'll be on the first test, whatever it is, a week from today, right? Isn't it? Yeah, a week from today. This is probably the hardest type. So when you have denominators, what gets rid of those denominators is multiplying by the 2 in the top. That makes sense? 2, 2, 2. And these ones cancel. Do you see why we didn't go 2 times 19? Because it canceled, huh? It's not there anymore. And we didn't go 2 times 1 because it canceled. It's just 1. But here it multiplied times the negative 5 because there was no denominator to cancel it. Good to there? And now, so that's step 1. Step 2, now we just, you tell me x is saying I want to be alone. So what do we do to get x alone? The 1, right? X and I want to be alone. So get rid of that. Bring that down. Minus 10x, 20. Now what? Now what do we do to... What's the last step always?
Divide.
Always divide, huh? Whatever number is next to that x, the last step is we always just divide by that number, right? Step 1, clear the fractions, we did. Step 2, do your adding, subtracting, we did. Step 3 is always divide. We always end with divide. We divide by the number next to x. Now, do I divide by 10 or negative 10?
Negative 10.
Good. Same sign up. What would be the problem if I just divided by 10? Why would that not get x alone? What would that do? That would cancel the 10s, but the negative would still be there. X wants to be totally, totally alone. So that means you need negative 10, because 2 negatives, multiplied or divided, make a positive. That gets x totally alone. Anyway, yeah, so we always divide by exactly what's next to x. Huh? Same sign, same everything, exactly what's next to x. So what do we get then? Negative 2. How we doing? That's making good sense. What was that, Manuel? How we doing? Doing good? Questions I can answer?
When we find those problems, always if underneath is, let's say a 5, we multiply by 5.
Yes.
All of them.
Right. So you hear what Manuel said? He's right on the money. Whatever's under the bar, that's what we multiply all of them by. Yeah, why all of them? Because we do equal treatment, huh? If the 2 sides are equal, treat them the same, be equal afterwards. Yeah, exactly. So whatever's under the bar, that's what we multiply all of them by. So if there was a 3 and a 3, I'd go 3, 3, 3. Now, what if there was like a 2 and 7?
We get the lower
Yeah,
denominator.
common denominator, which would be you multiply them together, 14, and you do all of them, 14, 14, 14. Yeah, does that make sense? Common denominator, multiply it to all 3, like that. All right.
I remember.
All right. You can write an example of one of these harder ones on your 3x5 card, right? You get a 3x5 card you can use. I forget what I say in which classes. Yeah, so you get it. Yeah, and I'll talk more about it next Tuesday. We're going to crack Sam, and I'll get more specific. All right, let's try this one. So what's the first thing we're thinking of? Remember the 3 steps. What's the first step?
Get rid of fractions.
Get rid of fractions. Get rid of fractions. Yeah. And so what is it that's going to get rid of fractions?
And also we have a multiple.
Common denominator, right? 2 and 7? 14. So we'll put 14 and we go 14, 14, 14, 14, 14. All of them, huh? They all get a 14. In fact, I'll probably just bring it down to give a little room here. Good so far? So they all get a 14. And then cross cancels. These are the hardest kind that are on the exam next week. Cross cancel. If you can do these, you can do anything on that exam. So what do I cross cancel? Anything under a bar. Because these are 14s over 1 really, aren't they? Whole numbers are over 1. So over 1. Right? Over 1. So anytime you have something under the bar, it'll cross cancel into the 14. Does that make sense? Because the 14 is really in the top, isn't it? It's 14 over 1. Whole numbers are always in the top. They're over 1. So 7 goes into 14. So show that. Actually show that's really important and helpful to you. 7, because here's the mistake I've seen over the years is people will go, oh, 2 times 14 is 28. That's wrong.
It's divided.
They forgot to divide. They forgot to cancel. See what I'm saying there? So it's not 28. Don't do that. 2 goes into 14. 7 goes into 14 2 times, and the leftovers multiply. So 2 times 2, 4. And this is these guys multiply minus 14x. So far good on the left side? So 7 goes into 14 2 times, and the leftovers 2 times 2 makes 4. That good? Not making sense there? And so can you do the right side now? Do the same thing. Cross cancel. Multiply whatever's left over. Okay, so 2 goes into 14. 7 times 1 times 7 is 7. Bring down the 14x here. Oh, this is a crazy one. I didn't realize this was crazy. I'll show you in a minute. Anyway, let's keep going, though. It's a good practice. Plus 7 goes into 14. 2 times 1 times 2 is 2. Oh, no, this isn't a crazy one. Never mind. It's all good. I saw the 2 14x's, and I thought it was the same amount, but one of them's a negative. I didn't look close, so it's all good. It's all good. Because, if it was both 14x, they'd both vanish. There'd be no more x's. Anyway. So we made it out of the fraction.
So that's 2 2's are 1.
Good. Everybody see what happened there? Questions I can answer so far?
That's just the first step, right? Getting rid of the fractions.
Yeah, but that really is the most important. I think most of you guys can nail it from there. This is the hardest step for sure. Let's get rid of it. Yeah. Carlos.
On the beginning of the, it says 14, is that 14 over X?
Where are we at? Oh, 14? That 14 is multiplying all of them. That's what the parentheses mean. It's 14 over 1, really, because whole numbers are always over 1. But I don't care because x isn't a fraction. So I'm just going to say it's really next to it. I just don't have room to squeeze it in there. But it's really next to it. Yeah, it's multiplying next to all these. I just stick it in the top because I don't have room. Yeah. Good to there? Can you finish it now? So that the fractions are done. We have no more fractions. That's always step 1, right? Clear fractions. They're cleared away.
Keep going.
So keep going.
So now, what's the next one? Subtract. So we get the same result. 14x
Would you do that? Well, when we have x's on opposite sides, we do the opposite, right? Of the lower one. Who's the lower one? Yeah. And what's the opposite?
So
Yeah. Plus 14x.
now we have to give both the
That
x's.
makes sense? So whatever you do to one side?
So we're going to do the opposite.
That's what we always do. We have x's on opposite sides. So notice, everybody, we have x's on opposite sides. So I'm trying to drill that phrase in for you. When x's are on opposite sides, do the opposite. Of which one? The lower one. Which one of these is lower? Well, the negative one. So when x's are on opposite sides, do the opposite of the lower one. So you go, okay, here's the lower one. I'm going to do the opposite of him. What's the opposite of him? What's the opposite of minus 14x? Plus 14x. And whatever you do to one side, you must do to the other. Gonzo. So whenever x's are on opposite sides, you get rid of one of them by doing the opposite. Good? Good there. Keep going.
And does that simplify anymore? What's your answer?
the number.
Good to there. But now it's easy for me, right? What do we do next? X said I won't be alone. What do we do next? We save the 28 to last. We save the thing right next to x for last. So next step to get x alone, subtract that 9. We save the divide for last. Yeah, would it help if I write the steps up again? So the steps, but here, let's just put them on the board too. That will have them up.
Wait a minute. The steps are wrong on his place.
Between minus 28. That's what you do?
All right, so there is the game plan, right? So next step is get rid of that 9.
Send that one over there.
We get to there, and what's the last step always? Divide by the number right next to x, right? Divide by 28, divide by 28. Minus 13 28ths. Is that okay? Do you want to do another one like that? Questions on that one first?
We need to make another one. Like a 5 more.
Here? At this step? Mackenzie? All right. Yeah, I could. I've got lots of them here. Let's do that. You can go back in and you're doing the homework. If you want more practice, you can ask it to give you more, right? Just hit similar exercise. And you can also do it where it won't lower your grade. Like if you already got your grade 100% or whatever, you don't want to mess it up. When you go back in, you can ask it to only practice. Did you know that? When you go back in? When you go back in, it gives you an option. Just practice or improve your grade. If you already got 100%, you can just go back in and practice, and it'll just keep generating problems for you. So here's a new one. Let's try that one. Same kind of thing. Just trying that one. Different numbers.
Let's try the shot. This one is 20. You agree with me?
Okay, what are we going to most do this? I want to make sure you're off to a good start. First step, what am I going to do first? Remember the 3 steps. Step number 1, clear fractions. Do the fractions. So I've got, what do I have under the bars? 5, 4, 5. So 20. 5 times 4, 20, right? 20 is the common denominator. And what do we do with that 20? Multiply everybody by 1, huh? By 20. 20, 20, 20, 20, and 20. Good.
That time you don't care about the negative or the positive on the 20?
I didn't hear either, right?
So
Yeah, the only time we do is that last step when we're dividing by the number in front of the last step, then it's exactly the number in the front. If it has a negative, we use a negative. That'll be the last step. That's the only time we care about that.
So when you times the 20 by x, it's not going to be negative 20x?
It is.
Okay.
Oh, it will. But we're fine with that. Yeah. At the very end, we have to get x alone. So if there's a negative at the end, on the last step, we will use it. But for now, we're just getting rid of fractions. So now cross cancel, right? Those 20s are in the top. So cross cancel with anything under a bar. Cross cancel and multiply what's left over.
Yeah. And the second is 4 times 2, that gives 8.
Good job. Now I would show it. I think it'll be better. You're right. But show these crossing out. Actually show them. Yeah, because that way you won't get confused. Boom, and then you go, oh, it's just 4 times 2.
Yeah, that's why I put that point like that.
That's good too. But also now show these cross because you want to make sure you see they're gone. That's not there anymore, huh? They're gone. It's just 5 times 1. Yeah, that's why we're doing the 20 to get it to divide in there and go away. Right? 20 divided by 5 is 4. They're not all still there. We don't still have 20, a 5, and a 4. No, 20 divided by 4 is gone and became 4. Yeah, good. So we cross cancel, right? 5 into 20. 4 times. Multiply. What's left over there? Minus 8. This is minus 20x. Good so far? But actually show this canceling. It's really important. You want to show that canceling because you want to know the 5 is gone. He went into the 20. 20 divided by 5 canceled and we replaced it with 4. Because that's what 20 divided by 5 is, 4. That makes sense? We're just dividing there. 5 goes into 20. But when it does, it's gone. And then we have 20x. Four goes into 20. 5 times 1 is 5. Plus 5 goes into 20. 4 times 2 times 4 is 8. So that's the hard stuff. Keep going. Now, X is yelling out. I want to be alone. You got X's on opposite sides of the wall. Good. Keep going.
You're right.
No, I think that helped me better. Because if I put everybody else in there, they're like, they're like easy.
All right, what do we do when X is on opposite sides? Do the opposite of the lower one, right? Who's the lower one? Negative 20. So we add 20x. Whatever we do to one side, got to do the other. These cancel. That's why we did it, to get that to drop out. Is that making sense? Whenever we have x on opposite sides, we do the opposite of the lower one. Not good. So what do we get? Minus 8 is 40x plus, and those are 13. 5 and 8, 13. That's good.
And then we need to
Say that again. You added the
the
8.
other side.
Yeah, always do it. There's nothing wrong with it, but it's not the quickest way to get there. You'll end up having to move that 8 back there.
These cancel.
Yeah, just always do the x's first. When you have x's and minus, so always do those first.
And then give you minus 21.
We good? So now x is saying I want to be alone on my side of the wall. X is over here. Sometimes he's on the left, this time he's on the right. X is saying I want to be alone on my side of the wall. So who are we going to get rid of?
The 13.
The 13, and then eventually the 40. We always say the thing right next to x for last. So get rid of the 13 first off. Gonzo. And so we got minus 21 is 40x. Last step is always, divide by the exact number in front of x. Same sign, same everything. Exactly what's if I was a negative 40, I would divide by negative 40. So regular 40, I'll divide by regular 40. Whatever's in front of x, exactly that number we divide by. That's always the last step. That's always how we wrap these up. Divide by exactly what's in front of x. Boom, there it is, minus 21 40ths.
And that 40 becomes minus 2, no?
Well, the whole fraction is minus.
Oh.
We don't think of the minuses on either one in particular. It's on the whole fraction. Even though I guess it's sitting on the 21, it's all the same thing. It's on the whole fraction. We good? We need to move on to other things. But there'll be plenty in your math Excel homework. We'll come to some other hard ones too. All right. I know. There's plenty more practice coming. Okay, that was a good one. But although it was wrong. It actually says even. Thank you. I better read. Always read. I was really trying to show you something. Yeah. You need to read carefully.
At the end, when you write it in algebra, that's the way you have to write it.
What's that?
At the end, when you write it in mathematical terms, that's
Right.
how you put it. Like
Right.
in algebra.
I made a small mistake though. Let's go back. They actually said 3 consecutive even numbers. And they even. So now what? So what? How does that change it? What, yeah. So that'd be like 16, 18, and 20, or 42, 44, and 46. 3 even numbers in a row. Okay. So how much do these go up every time? Goes up by 2. So instead of and x is still the first one. We still start with x. But the second one now doesn't just go up by 1. It goes by 2. And the next one, 4, another 2. Just go up 2 more every time. Does that make sense? Because they said they're even, so they have to go higher by 2 every time. Now, hold on. What if they had said, because I think you mentioned yours says odd. Yeah, what if they had said odd?
We do like the first time.
So what if they said odd? Think about odd numbers, like 11, 13, 15, or, 29, 31, 33. There's 3 odd numbers in a row. A couple examples, right? So you tell me, starting with the first one, how much you go up every time?
14.
How far from 11 to 13?
2.
And how far from 13 to 15?
Oh, okay.
It's still 2. Even and odd numbers have the same jump. You go up by 2. No difference. So you do the same, whether they say even or odd, that still means a jump of 2, doesn't it? From odd number to odd number goes up by 2, just like even number to even number goes up by 2 every time. It'd be exactly the same for even or odd. For even or odd, it would be exactly the same. Does everybody see that? Because from odd number to odd number, you go up by 2 every time, don't you? Just like from even number to even number, you go up by 2 every time. There's no difference. Is that good? I've had students over the years, they'll go, wait a minute, sir, but that's an even number. That's an even number. That won't work for odd. What they're getting confused on is that's the jump amount. That's not the number itself. That's how much it goes up by. From odd number to odd number, you do go up by 2, an even amount. That's true. And it's still an odd number, you see? That's the gap. That's the gap between the numbers.
We find the numbers, but to write it in just in one line.
Yeah, so now we got to finish. So now we got to add these up. I'm not doing the last step. So now we add them up. They want the sum. So x plus x plus x, 3x like we just said, and 2 and 4, 6. That's our answer then. That's the actual answer. Is that making sense? So even or odd goes up by 2 every time. Is that good? They're saying the first one's K. There's 4 odd consecutive numbers. So what's the second one? K plus 2, because odd number to odd number, you go up by 2 every time, don't you? Go up by 2. The third one, the next one, goes up by 2 more. The fourth one is K plus 6. So they just keep going up by 2 every time. From odd number to odd number to odd number, just keeps going up by 2 every time. And then they want the sum. The sum, they want you to add them all up. K, 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 K. 4K. 12. Yeah, it sounded like a bad organization. Yeah.
It's coming. You see that the movie? It's going to be a good movie.
What's that, Carlos?
You see that?
Right up there is the odd number.
Right.
But then you're putting 2, 4, 6 even.
Right. Good. So it's still true because if you think about odd numbers, let me just make up an example now, like 11, 13, 15, 17. What is the jump from odd number to odd number? It's still 2, huh? So the jump. So this is just the jump amount. So it's actually right. Odd numbers do go up by 2 more every time. Yeah. Seems weird, I know, huh? Well, that's even. Let's do not, but it's right. Yeah. Good. Other questions on that one? All right, good. So there's our answer. All right, we have finished that.